had a very tough day and decided to go to the roof of her 300-meter tall building to have some peaceful moments. Drinking a bottle of water on top of the building was the best at that moment. After finishing the water, a very strong wind started and threw upward the plastic water bottle with an estimated velocity of 100 meters per second.
So now what we have to do is A. Write the position equation for the plastic bottle. B. Find the equation of the velocity for the plastic water bottle using the derivative definition with limits. C. Calculate the acceleration equation for the plastic water bottle. D. Explain the form of the obtained equation. E. Calculate the height of the bottle after 2 seconds. And F. Calculate after what period of the time the bottle hits the ground.
Let's get started. Got nothing in my brain.
Okay, so now we're going to start the flowchart. Start. First, we have to read and analyze the problem. Then, we have to find and write the position equation for the bottle. Next, we have to find the equation for the velocity of the bottle using limits. Then, we have to calculate the acceleration. Next, you have to ask the question, did the acceleration, velocity, and position equation are correct? If the answer is no, you have to read and analyze the problem again. If the answer is yes, you have to explain the obtained equation. Then, you have to calculate the height after 2 seconds. Next, you have to calculate the period of time in which the bottle hits the ground. Then, you have to review your answers. And that's the end of the flowchart.
Mathematical model for solving the problem number 2, A, is to find our position equation. F of x equals initial velocity times t plus acceleration times t squared over 2 plus initial position. Now we substituted these values on our initial position equation and then we solved it. Now we're going to solve B, which is find the equation of the velocity for the bottle using the derivative definition with limits. Our equation is limit when delta t approaches 0 equals f of x plus delta t minus f of x over delta t. Now, with our position equation that we previously got, we're going to substitute in this formula and we're going to solve it. Our result was f of x equals minus 9.8 meters over square seconds times t plus 100 meters over seconds.
Mathematical model for problem 2, letter C. First, we need these variables to solve the equation. It was f of x equals negative 9.8 meters over second squared times time plus 100 meters over seconds, and we use the formula limit of delta t as it approaches to 0, v times x plus delta t minus f of x over delta t. Then we substitute the formula with the variables given, and then we obtain our result, that is acceleration equals negative 9.8 meters over second squared.
To explain the form of the obtained equation, we just need to see the position equation and analyze it. We have that y is equal to minus 4.9 t squared plus 100t plus 300. Now we know that this graph is a parabola that is upside down because we have t squared and then we have a negative in the coefficient. Also, we have that the y-intercept is going to be 300 because the problem says that the building is 300 meters tall. So you actually start at 300 meters and then the ball goes up and then it falls down to the ground again.
Okay, letter E. We need to calculate the height of a bottle after 2 seconds. We use the formula f of x is equal to initial velocity times time plus acceleration times time squared over 2 plus its initial position. We substituted everything that we have with our values and solved it out. Our final answer was f of x is equal to 480.3 meters.
Now to calculate after what period of time the bottle hits the ground, we have to use the position equation that we already have and the general formula. The final result is minus 2.65. Now, since time cannot be negative, we use the value of 23.06 because that's the only possible answer.